Thank you all for joining. My name is Johanna Zikulnig, and I work as a scientist at Silicon Austria Labs in the field of printed and sustainable sensorics. For those of you who don't know Silicon Austria Labs, just a quick introduction. So we are a non-university research organization working along the value chain of electronic-based systems in Austria with more than 350 scientists working in different fields in 3 locations, in Villach, Linz, and our headquarters is in Graz. And working along the value chain of electronic-based systems, we take that seriously because we have expertise in sensor systems, power electronics, microsystems, embedded systems, and intelligent wireless systems. I'm in a department of sensor systems, and we see some growing trend in sensors development. So with the digitalization, there is the trend of ubiquitous sensing, with the sensor market growing at a continuous compound annual growth rate of 8.9%, with driving fields in Internet of Things, healthcare, and automotive. But at the same time, single-use applications are emerging, like point-of-care diagnostics, which are disposed of quite quickly because of hygienic restraints, and also there's a significant growth in the smart packaging market. This comes with some certain implications, like, for example, the more sensors and the more disposable electronics is produced, there is an increased raw materials demand. At the same time, some of those devices are manufactured by energy-intensive technologies. Often they use scarce or toxic raw materials. And when they reach the end of life, which is sooner than later for disposable electronics, there's the growing issue of electronic waste. But not only electronic waste, especially those single-use applications, they might end up in municipal waste. So they won't come into any electronic waste stream at the end of their life. So in this context, printed electronics is often mentioned as the cure to everything. It's so green, it's sustainable. There are hundred thousands, I guess, of publications around which claim sustainability. Sustainability, biodegradability, green, and so on. And however, those often just provide more or less a qualitative idea. They use the term sustainability just for the sake of it, without giving any quantification. So how can it be quantified? There's this tool called life cycle assessment, in short LCA. I will call it LCA in the following, which is a systematical tool to evaluate the environmental impact of a product or process throughout its entire life cycle. The life cycle can be modeled as a process from the raw materials until the end of life. 1 second, this is the pointer, yeah, until the end of life, and then in a circular approach from the end of life, this feeds back into the raw materials, you know, if you are using recycled materials, for example. While a product's environmental impact is mainly generated during the production and the use and the end-of-life stage, it is very important to consider it already early in the development and research process, because in the design phase, most of these impacts are determined. LCA is also standardized, and the global warming potential is a key indicator used in LCA, which expresses a product's climate impact in terms of CO2 equivalents. So there are lots of metrics that are used and are very valuable in life cycle assessment. However, within this study I will be presenting, we will focus on the global warming potential, also because of the data availability. I will come to that later. Okay, so that now I explained what an LCA is, but what is actually the purpose of an LCA. So using LCA, you can create more value with less environmental impact, so to say, if you really interpret and use the data and the insights that you generated through an LCA. With this you can say, actually, there's a term, you can enhance the eco-efficiency, which means, on the one hand, enhancing the quality, value of a product, process, or service while reducing the environmental impact. For printed electronics, we can say that actually printed electronics can increase portability, applicability, the level of integration. At the same time, it can reduce costs. And on the other hand, for reducing the